All right, so going over adding and subtracting again with rational expressions, specifically using fractions here. And so when we are adding or subtracting, the first thing we're always going to do is find a common denominator. So we'll find a common denominator. That's going to involve factoring both if possible. So for this, I'm going to factor x squared minus 5x plus 6. That means I need something that multiplies to 6 and adds to negative 5. So depending on how you organize it, it multiplies to 6, adds to negative 5. Since it's multiplying to get a positive, both are going to have to be negative in order for that to be a negative. So the one that works for that, -2, -3. So this one is going to be factored out x minus 3, x minus 2, just over 3, plus my x squared minus 4. That's difference of squares, and so that just means I take the square root of both. It's going to be x plus 2, x minus 2. Okay, and so I don't need to have, that's a 2 up there. I don't need to fully combine everything, so there's no need for me to put both of these terms over here, both of these terms over here. If they were exactly the same, I'd just say, okay, great, we're the same and we can move on. But what I'm going to do is look for what this one is missing from here and what this one is missing from here. So for my common denominator, it's going to be, and we can go ahead and write down all of those first terms, x minus 3, x minus 2, and then I have an x minus 2 here, but I don't have an x plus 2, so we need an x plus 2. And so they have the x minus 2 in common, but in order to get the bottom of both fractions to be exactly the same, I'm going to need to multiply both by something else. And so what's going to happen is this first one is going to have to multiply by an x plus 2 because it's lacking an x plus 2. And that means both top and bottom have to be multiplied by that in order to fit our multiplication rules, in order to allow that to happen just with this one here. Then this one is missing an x minus 3. So I'll multiply top and bottom times x minus 3. And what I get is two that have a common denominator now, and it's the smallest common denominator that we can get with this. So next step, I'm going to distribute or combine for both my numerators. So both those numerators, when I am adding or subtracting, I'm going to distribute for both of them. So the 2 is going to go into both of those, the 3 is going to go into both of those, and we are at the same time going to take and put it just over one common denominator. So when I combine here, 3 times x is 3x, 3 times 2 is 6, and plus 2 times x is 2x. 2 times negative 3 is negative 6. And all of that's going to be over my common denominator, x minus 3, x minus 2, x plus 2. Then I'm going to combine any like terms in the numerator. So 3x and 2x will combine together to give me 5x. And 6 minus 6 cancels each other out. And so once I've done that, just put that over my factors here. And simplify if possible. Which, looking at it, there's not a 5 or an x that's out on its own that I can cancel out. So this is going to be my answer for this. And you might say, well, why don't we multiply all these together to get a trinomial or a quadrinomial? And there's no reason really to do that, just because when I do that, you've got addition and subtraction signs in the middle of them, and the only way I could cancel out is if things are just being multiplied. If I have, like for instance, I couldn't say this x and this x cancel out because this x has a 3 subtracted from it and this one doesn't. And so since that doesn't have it, I can't cancel it out unless if there was an x up front being multiplied by it, then yeah, I could do that, but not with this. So there's no simplifying that's possible here. Okay, looking at number 2, we're going to start out by finding a common denominator, which means I've got to completely factor both. So I notice real quickly here that all of these would divide by 2. So if I pull out a 2, I get x squared minus 3x plus 9. And on that, this I don't think is going to factor out simply. My factors of 9 are going to be either 1 and 9 or 3 and 3. They'd all have to be negative, and none of those are going to get me to a negative 3. So we're looking at something that's a fraction or a decimal for my 2 factors. So for right now, I'm just going to leave that as is. For my x to the third power plus 27, that's going to be sum of cubes. So when I'm doing sum or difference of cubes, I have to figure out the a and b value. So the a value of this would be the cubed root of that x to the third power, which would just be x. And then b is going to be the cubed root of 27, which 27 splits up into 3 times 3 times 3. So the cubed root of 27 would just be 3. And so for my sum of cubes, it's a plus b. So x plus 3. And then remember, they have the acronym of SOAP. And you've got your notes for that. But that's just so you don't have to use the notes. We've got one of the A's, one of the B's right there, same sign. And then it's going to be opposite and always positive. So the opposite of that it's negative, and then this one's always positive. And so the way my trinomial here sets up is I'm going to have a squared and a to the first power here, and then no a at all. And working backwards, b squared, 1b, no b at all. So the first part of that would be a squared, which is x squared. Then I have 1a and 1b, so x and 3, give me 3x. And then b squared, so 3 times 3, which is 9. And so that's all factoring out both of those, all to get my common denominator, which is going to be, and what I always do for my common denominator is I write out the first denominator I have, and thankfully for this, they've given us the same trinomial here. The only thing I'm missing is this x plus 3. And so that means my first fraction here is going to have an x plus 3 added to it, or multiplied into it. My second one is going to have this 2 multiplied into it. So, writing that out, I'm going to have 5 times x plus 3 over 2 times x squared minus 3x plus 9 times x plus 3. And then I'm going to put my subtraction sign, and I'm multiplying both these by 2. So 2 times 2x plus 6 over 2x squared minus 3x plus 9 times x plus 3. So I've got that multiplied in, factored both, found the common denominator. Now I'm going to combine and distribute. So for this, that means both these will be multiplied by the 5, and I normally change this to a positive and put the negative distributed here. That way I don't forget it. So distribute a negative 2 for that. And that is going to get me to where I can have those combined. So this would be 5x plus 15 minus, so negative 4x minus 12. And all of that's going to be over my common denominator. So just to save a little bit of time there, put CD for my common denominator. And I'll have 5x minus 4x gives me just an x. 15 minus 12 gives me plus 3. So when I put that simplified out with the 2x squared minus 3x plus 9 times x plus 3, I end up with an x plus 3 here and one down here. So my final answer, when those cancel out, this leaves a 1 up top. And so I have 1 over 2x squared minus 3x plus 9. Okay, looking at the next one. Unbox my answer there. Again, I need to find my common denominator. Do that by factoring both. So something that multiplies to 1, adds to negative 2, is going to be x minus 1, x minus 1. Negative and negative makes a positive and gives me that negative 2. For this one, I'm going to have x plus 2 and x minus 1. So that, again, is going to multiply to give me what I need. My common denominator will be, again, writing out the first term and then whatever's missing from the second. I do not have an x plus 2, so that'll need to be added to it. So I've got my common denominator. Now I need to multiply in whatever's missing. So here I'm missing an x plus 2. It's multiplied by the top and bottom. And then this is going to be multiplied by x minus 1. And so everything's going to get multiplied together in my numerators. So for my first one, I'm going to end up with x plus 2 times 1 is going to give me, or x plus 2 on top. And I've got my common denominator on the bottom. Minus x plus 1 times x minus 1. I end up with x squared. A positive 1x, negative 1x, so those cancel out. A minus 1. And then all that's going to be over, again, my common denominator. I'm also going to need to distribute a negative. So since I'm subtracting that, we will change that to addition. Make that a negative, this one a positive. And what I end up with is an negative x squared plus x plus 3. All that is going to be over my common denominator here. And so I run into an instance where I need to factor this out if possible, just to see if anything will cancel out. And so I'm going to pull out a negative 1 first. So if I pull out a negative 1, it's going to make that positive. This is going to turn negative, and that's going to turn negative, just so that my factoring works out. See if I can get something that multiplies to a negative 3, adds to a negative x there. And so looking at that. And so on that, don't have anything. So making negative 3, they'd give me a negative 2. So nothing works out. So I just end up with that over my common denominator. So and that would be my answer.